Unit 6, Day 3. Again, no review days, no review days, no review days. Please don't get behind. Again, overall, the name of the unit is Sequences and Series. Sequences is the set of numbers. That was Day 1 and 2. Series is the sum of numbers. That's Day 3 and 4. And today's Day 3, if you lost count of where we're at here. So a lot of stuff is similar, except instead of just a list of numbers, today we're going to have a sum of numbers. So instead of, and be careful, I don't have commas there, 3, 6, 9, 12, 15, 18. Instead of separated with a comma, we're going to have a plus in there. Let's go ahead and go one more, 21. That is a series because it's a sum. So it's not just a list of numbers anymore. It is a list of numbers, but instead of just sitting there with the list, we're going to add the numbers together. Now, there's a shorter way to write that, rather than writing them all out like that. And the shorter way is using summation notation. It's just fun to say. Summation notation. I think you've seen this before. That it's the Greek sigma. The Greek S for sum. So it doesn't look like, an American English S, but it's the Greek S for sum. N equals 1, that's our lower limit. Lower limit because it's our first term, but lower limit as in it's also the lower limit on the, just like on the picture, it's lower than the upper limit is the top number. So 7, that's our upper limit. That's our last term. Lower limit is the first term. So the sum from n equals 1 to 7. 1, 2, 3, 4, 5, 6, 7. There's 7 terms. And then what comes next is the formula. The formula that would give us these terms. So this one's not too bad. If n is 1, n is 2, n is 3. So the term is just 3 times the term number, so 3n. So this is a fancy way to say the sum of all these numbers. Here's our formula. Plug in n equals 1 first, and then count up 2, 3, 4, 5, 6 until you get to 7. In fact, how we would say that is the sum from n equals 1 to 7 of 3n. So we're adding up 3n's, starting at 1, ending at 7. Let's do a couple of examples with that notation. Let's expand sum from n equals 3 to 8 of 1 over n minus 2. So 1 over n minus 2 is the formula we'll use. N equals 3 is the first n we'll plug in, and then we'll plug in up until 8. And it's maybe overkill to start with, but I'm going to plug in 3, 4, 5, 6, 7, 8. You don't have to write those out, but if you don't write them out, sometimes people get lost. They're like, wait a minute, what did I plug in? What's left? So if I plug in n equals 3, 3 minus 3 is 1. If I plug in n equals 2, 4 minus 2 is 2. If I plug in n equals 5, 5 minus 2 is 3. And at some point you probably get the hang of the pattern and you stop plugging in and you start using the pattern. Like, I'm pretty sure the next one's 4 in the bottom. Let's plug one more in to make sure. 6 minus 2 is 4. So I feel pretty good about the pattern. I'm no longer plugging things in. I'm just following the pattern. Okay, a couple of things. Expand means you don't actually have to add. You just expand it all out. You don't have to evaluate. Also, how many terms are there in that expansion? 6. Okay, so be careful. That top number is sometimes the number of terms, but not always. So be careful. If you start at 1, it's great. Then it's just the counter. But if you start not at 1, then it gets a little confusing as to how many terms you've got. All right, let's go backwards. Let's write 9 plus 3 minus 3 minus 9 minus 15 minus 21 minus 27 as a summation. So it's the backwards problem. Here it is all written out. We want to go backwards and write it as the sum from n equals something to something of something. We got a lot of blanks to fill in here. Well, you get to pick what you start with. So if you get to pick, I would almost always start with 1, because that's going to be the easiest thing to keep up with.
When don't you start with 1?
So if it's your pick, I would always start with 1. Occasionally, there could be a series that is easier to start with something else. It's like if your series was, here's a real easy one, 4 plus 5 plus 6 plus 7 plus 8, you might want to go from n equals 4 to 8. Oh, not infinity. Because that's an easy one to see that you could start with 4 and end at 8. But most of the time, it's going to be wiser to just start with 1. 1, 2, 3, 4, 5, 6, 7. And we'll go to 7 because there's 7 terms. Okay, next I need the expression or the formula for my terms. Well, this is what we did on Friday. Is this an arithmetic or a geometric? Arithmetic, because what's the common difference? Negative 6. We're subtracting 6 every time. So a1 plus d times n minus 1. In fact, we're almost there. The first term is 9. D is negative 6. N minus 1. You could use that. Most people would simplify. So 9 minus 6n plus 6 would be negative 6n plus 15. And so they would plug that in over here. And if you'll take the time, it's easy to check that you did this right. Plug in 1, and I get 9. That's good. If I plug in 7, I should get negative 27. Let's see, negative 42 plus 15. Yeah, that's negative 27. So if you'll take the time to check your work, you can usually figure out that you got it right. Let's do another one where we work backwards. That's right. 400 plus 200 plus 100 plus 50 plus 25 plus 25 over 2 as a summation. Sum from n equals 1 to how many? Where do you want to stop? What's the last term number? 6. So we'll go from 1 to 6. And then I need an expression for or a formula for which term we're at. What kind of series is that? Geometric, where r is 1/2. So first term times 1/2 to the n minus 1. And then there's no simplifying on that, so 400 times 1/2 to the n minus 1. Then we're done. That's it. We're going to look at 3 different series. So we're going to make kind of a table here with 3 different entries. The sum from n equals 1 to 20 of 7n plus 2 the sum from n equals 0 to 19 of 7n plus 9 and the sum from n equals 2 to 21 of 7n minus 5. And we're going to compare their number of terms, find their common difference, figure out what the first term and the last term are. A lot of information, but it'll go quick. So this first one, from 1 to 20, how many terms are there if we start at 1 and count to 20? 20 terms. All right, if we don't start at 1, things get a little tricky. If we start at 0 and count to 19, how many terms is that? Okay with that being 20? It's kind of weird. Some people have to be like, okay, 0, 1, 2, 3, 4, 5, 6, and count up that way. But yeah, that's 20 terms as well. What about if we start at 2 and go to 21? How many terms is that? It's not 19. It's 20. If you do 21 minus 2, that's where you get 19 from. That means you didn't count the second term. You subtracted off the second term. Just like 20 minus 1 would be 19, but you didn't even think about that. You just said, well, 1 to 20, that's 20 numbers. 2 to 21, that's also 20 numbers. Are we familiar enough with the formulas to recognize what the common difference is without actually finding a bunch of terms? What's the common difference for this first one? 7. And how about for the next one? And the next one? First term, that just means plug in whatever the bottom limit is, the lower limit. So 7 times 1 plus 2 would be 9. What about on the second series? If I plug in the bottom limit there, 9. And then on my last term, if I plug in 2, I get 9. Interesting. How about, let's check the last term. If I plug in the top number, 7 times 20 is 140, plus 2 is 142. Now the others are a little harder on the math, but if they have the same number of terms and the same common difference and the same first term, what do you think about their last term? It's going to be the same. And so all three of those, even though they look very different, it's the same set of numbers. So this is what happens when you start at 1 versus 0 versus 2. Things look different, but it could still be the exact same set of numbers. So this is where you have to be careful, and where I have to be careful. If I ask you for a formula, you could give me any one of those, and those would all be correct. Now, most of you are going to start at 1, because that's the easiest one to do, but there are always more than one way to write a series. Right. What we haven't done yet is actually add the numbers. One way to add the numbers is, just like physically add the numbers. But there's formulas that make this a little easier. And these formulas will be given to you. Okay, so the formulas from Friday, not given. The formulas today, given. So we'll talk more about that tomorrow. But the sum formulas we will give you. The sum formulas will be given. So here's the arithmetic sum formula. S sub n, meaning the sum, is n times a1 plus an all over 2. Again, we will give that to you. Sn is the sum of the first n terms. Most of these make perfect sense as what they are. N is the number of terms. A1 we have to be a little bit careful about. It's the first term, not necessarily A of 1. Right? Because if you start with 2, then A2 is the first term, and you'd have to use A2 there. Does that make sense? So when you use this formula, A1 represents the first term. I don't care what you called it. If it's actually 3, 4, or 5, whatever the first term is, that's A1. Which is another reason to start your series with 1, because it makes this formula a little bit easier to deal with. An is the last term, so whatever the last number you plug in. So let's evaluate, meaning get an answer, not just list out the terms, for the sum from n equals 1 to 100. So clearly we don't want to write out all these terms, whatever this is. I have to be typing forever. Of 4n plus 3. So if we wrote out all those terms and we added them all up, I would like to use this formula as opposed to writing out 100 terms. So the formula, I'm going to write it again here. N A1 plus AN all over 2. So I got to find all the pieces and then I'll plug them into the formula. So what's N? How many terms are there in this series? 100. You start at 1, you go to 100, that's 100 terms. Again, be careful if it doesn't start at 1, then you've got to be real careful about how many terms there are. But if it starts at 1, all is well. For A1, we'll plug in our bottommost term. So 4 plus 3 is 7. That was easy. For our last term, we'll plug in the top number. So I plug in 100, that would be 403. And now I've got all my pieces. So N is 100, A1 is 7, AN is 403, divided by 2. So 100 times 410, all divided by 2. By the way, you don't have a calculator on this test, so you need to be able to do some of this math by hand. Which one of those numbers would you rather divide by 2? Either one will work, but one of them will make life easier later, I think. Do you want to divide the 100 or the 410?
The 410.
I would do the 410 because multiplying by 100 would be easier. If you divide by 100, if you divide the 100, that's fine. Then you got to do 410 times 50, which, I mean, that's not hard, but multiplying by 100 is a lot easier. So I would group the 410 and the 2 and have 100 times 205. And then I just need to put 2 zeros on the end of that. 20,500. So a pretty handy formula, because you don't want to list out 100 terms and then, especially without a calculator, but even with the calculator, typing in 100 things to add them all up. You don't want to do that. I suppose to check, you could, just not really recommended. All right, the geometric sum formula, also given, so you won't have to memorize this. A1 times 1 minus r to the n all over 1 minus r. Again, given. I don't know if we tell you which one's which, but it's pretty easy to know which one's which in terms of arithmetic versus geometric. How can you tell, looking at those two formulas, if they weren't labeled, how would you know which one is the geometric one? The one with R in it. So I don't remember if I label them or not, but because of the R, it's pretty clear that that's the geometric one. All right, S sub n. So some of these are the same thing. S sub n is the sum of the first n terms. A1 is the first term. Again, it doesn't necessarily mean you plug in 1. It means you plug in whatever the first term is. N is the number of terms. And R, you already know that's the ratio. So let's evaluate the sum from n equals 1 to 6. The sum from n equals 1 to 6 of 7 times negative 2 to the n minus 1. So one way to do this would be to find all 6 terms and add them up, but we don't really want to do it that way. We would like to use our formula. So I need A1, I need R, and I need N. A1, plug in the bottom number. So let's see, 1 minus 1 is 0. This works out well. What's the first term after all that?
Negative 14.
1 minus 1 is 0. What's negative 2 to the 0? 1. And 7 times 1 is 7. Our first term is 7. In, how many terms are there? If we start at 1 and go to 6, I should have put a trickier one on here. If we start at 1 and go to 6, 6. And then R, can you tell what R is by looking, or do you want to find some terms to make sure? Let's see, A sub n, I'm just thinking back to the geometric formula. If you can tell by looking, what is it? Negative 2. It is negative 2. If you're not sure, then you plug in some numbers and you realize, okay, yeah, R is negative 2. So if you can tell by looking, great. If not, then do some work to figure out what it is. All right, so now we've got all our pieces. Let's plug them into the formula. First term is 7. 1 minus 2 to the 7th. Wait, that's not quite right. It's 1 minus negative 2 to the 6th. All over 1 minus negative 2. I gotta wake up here. So 1 minus, what's negative 2 to the 6th power? 2 to the 6th is 64. And then 1 minus negative 2 would just be 3. So 7 times negative 63 over 3. This actually works out okay, because 63 over 3 will reduce to negative 21. And then times 7 would be 147. Negative 147. Again, no calculator, because we don't want you to just list out the 6 terms and add them up. We want you to use the formula to find them. But that does require a little bit of work. Alright, Unit 6, Worksheet 3. Again, test is Wednesday, no review days, so make sure you're keeping up with this. We will have time on Wednesday to answer a few questions, but don't wait till the end, because then you won't have time to, kind of process it all. We do have a block day on Wednesday.